Hi, everybody. Wonderful. So today I'm going to be talking to you about node-based shading. Apparently, I'm quite knowledgeable on it because I've been doing it for a couple years now. And first, let me just give you a little bit about myself. Let's see. So who am I? Well, I go by the username ShaggyMummy pretty much everywhere online. If you find somebody by the name ShaggyMummy, most likely it's me or somebody pretending to be me. Right there's my Discord tag as well, my email address, and I also run a multimedia production company with my brother called 3 Ribbon Studios. Other stuff I do is I primarily come from a video production background, so I do a lot of live bands and other stuff. So for instance, Wesley and the Crushers, those guys look kind of familiar. Hello, yeah, my avatar is based off of these guys right here. Check out their videos, pretty much every video on their YouTube channel I've made, as well as the Blue Stage. That's a local music venue that I do video production for. In addition to that, I've also made several VRChat maps. Infinite Highways, probably notably the best one that I've made, or at least the most popular, thanks to it being featured on the VRChat hub. And then the Virtual Studio Udon is a lighting studio that I've been making for the past 2 years. Let's see. Other things I've been doing, I recently made a tutorial using my Kintsugi Simple shader, which is actually up for sale on Booth. If you scan that QR code, that'll take you to the Booth page, and the tutorial there is linked, and I'll be going over a rough overview of the texture baking section of that tutorial later on. So, node-based shading. First, let's go over some pros and cons. That's all right. Pros to node-based shading is you can basically seamlessly texture any 3D model, whether it's a photoscan or a 3D sculpt. It doesn't particularly require good UVs. You can just unwrap the UVs using the automatic unwrap, and as long as you don't have anything overlapping or you know what you're doing, you can bake anything to these models. And if you do it procedurally, you can effectively have infinite resolution. You don't actually need textures because you can do it all with procedural noise. And you can actually use these node-based systems to enhance existing textures. On a couple different projects, I did some basic terrain shaders where I did other they were tiling textures, and I was able to use I believe it's a node group put out by Andrew Price on Polygon, and it's free. And what it does is it skews the UV coordinates of the textures and allows you to cover a large area with 1K texture, and it doesn't even look like it repeats. It's really great. And then the other thing is you can do dynamic effects. You can have animated, for instance, one of the examples I have is a laser going through fog. And it's kind of faking volumetrics because, of course, you can't actually do volumetrics. Cons to procedural shading is it's render intensive. If you have a lot of math operations, a lot of procedural noise, it will bog down and take a lot longer to render each frame. Of course, if you're doing animations or motion graphics, you're not running at 90 frames a second, only like 24 at most, up to 60. And the other con is not all node-based shading systems are the same. I'm most familiar with Blender, but I've also tried learning Amplify. A lot of stuff translates, but also a lot of stuff doesn't. For one, the noise generators in Blender are a lot more refined. You have a lot more control over each parameter, and I think they're more optimized as well, so they can actually run at closer to real-time speeds. And Unreal also has a node-based shading system. I've never used it, but it looks really cool. And as to anything worth learning, there's a learning curve. It's not going to be easy picking it up right off the bat. There's a lot to it, and if you don't stay organized, it can become confusing and very disorganized. So, concepts and principles to node-based shading. So firstly, we have our texture coordinates, and these are what actually tell all the procedural noise where it starts. You have several different versions of it, and it's all in one node, and each one has a different output. So we have our generated coordinates by default. This is what Blender sets up in its node-based system, and this is kind of a combination between generated UVs and world space. So it will stick with the object if you move the object around, but for the most part, it's the default for a reason. Next up, we have normal. Actually, I gotta up my resolution. Can barely read that. There we go. So next we have normal, and this just sort of lets you see the normal faces of the actual model itself. Next up we have UV, and this will actually show what the UV coordinates that you have of your unwrapped UVs. Another thing to note is you'll see the object in dropper right here on all of these, and what you can do with this is you can actually have this linked to an empty or another object itself, and then the generated coordinates will follow that. They will originate at the origin of that object. Next up, we have object coordinates itself. So this will have the coordinates always generate at the origin of that specific object, or it will override if you put an object in here. We have camera. This is basically screen space, but in addition to that, we also have window. The main difference is that where you have a camera in the scene, it will be screen space based on that. And I think technically this one's a vector 3, but this one's 2-dimensional, so it's a vector 2. And that's the main difference. A window, any sort of viewer window of your 3D view in Blender will have this used as its coordinates, whereas camera is strictly for cameras. And then we have reflection. So reflection is used if you want to fake reflection maps, and you just have a procedural noise that you can do a bunch of operations to and have fake lighting in your shader. Oops, let's go back. Next up, concepts. Procedural noise. I've said it about 15 times so far in the talk. This is sort of your building blocks of actually creating textures from scratch. We have various patterns and noise. So we have your basic noise. You can't really see a whole lot, but you can boost the contrast and get a lot of definition out of this. And you have all these different controls. Another thing to note is that these patterns, some of them are 2-dimensional, some of them are 3-dimensional. You can even have 4-dimensional. 4-dimensional basically means you have a seed value that you can control and you can have it animate over time. So we have a regular noise. We then have Voronoi, which is my personal favorite. If you want to do like a cell fracture or like dried up dirt or scales, that kind of stuff, it's really useful for that. And then we have Musgrave. This one's sort of a more clamped down version of noise. As you can see, it's a lot higher in contrast, and I think there's less data in the darker spots. The other thing to note is that these all produce black and white textures, so that basically 0 equals black, 1 equals white, and it's just a range in between. However, some of them will also produce color. So for instance, you'll notice the yellow output on each of these nodes, and this one even has a purple output, which means it gives vector data. So you can use all of this in basically any way you want. Moving on, so then we have the brick texture. Brick texture is one of those that is actually 2-dimensional, and there's an example I show later on where I have to have bricks on multiple walls, and so I create a mask using I believe the normal vertex data in order to segment off the ones that are facing north-south and the ones that are facing east-west. That way I can make it 3D. Then we have checker texture. This one probably is the easiest to see how it's 3D, where normally a checkerboard you would see on a 2-dimensional plane, and it's just squares. But because we have on this head, you can see it goes in the Z depth and you get these weird diagonal lines, and that's where you can actually see it producing the difference of color based on its depth. And then we have magic texture. I don't use this one a whole lot. I probably should. It looks nice. Haven't really used it. Take a quick drink of water. Alrighty, math. There's a lot of math in this stuff. I don't know a lot of the math, but I know some of these are useful. I use add, subtract, multiply. Occasionally I use greater than, less than, power. And then there's all this other crap that I'm just like, okay, if you know how to use it, that's great. I don't, so I don't. Another side rant is in Blender, it's one node. If you want to do a math operation, you put in a math node, and then you can choose from the drop down and you pick your operation. In Amplify, there's one node per operation. I hate it. Okay, more nodes. We got data nodes and normal nodes. I kind of put these together because they're also very useful. So first up We have our geometry, and this just gives us various data points about whatever mesh that we're reading from. Position is quite useful. Normal, that's actually the same normal that you're going to get from your texture coordinates. We have tangent, true normal, incoming. The one I use the most, honestly, is backfacing. So for instance, in the viewport, you can actually turn on backface culling for just the preview mode. But if you want to have backface culling in your actual shader, you can get a black or white value based on the normals of whether the face is front face or back face. That's quite useful. We then have layer weight. I use this all the time if I want to make something look edge lit. It gives you Fresnel, and it just it gives you a gradient from white to black, whether or not the face is facing you or not. Bevel, this one actually looks at the geometry and allows you to create a faked bevel on your mesh without actually having to add geometry. It just writes it to the normal data. Ambient occlusion. We all pretty much know what ambient occlusion is. It adds shading to areas that are near each other and allows you to fake lighting. And then we move on to bump and displacement. These two are almost identical. The only main difference is that if you are using cycles, which is Blender's ray tracing engine, you have to enable a certain setting, and then it will actually displace the geometry of the mesh. Not particularly useful for VRChat or Unity, but it's a thing that it does, but it only works in cycles. Otherwise, it works completely functionally identical to bump, which I use more than I do normal, because normal needs to have a specific texture type in order to have the data be usable. Whereas a bump map is just black or white values, is higher or lower. That's all it's really doing. So because a lot of the noise generators produce black to white values, I primarily use bump. Normal's there if you're working with existing textures. For instance, if you have terrain textures, you would have your bump, normal, roughness, whatever. That's when you'd use that. And then we move on to the actual shader nodes. So these are what you would be able to plug in your textures to normally in order to just produce whatever textures. I'm going to go over the principled volume real quick. The way Blender and Eevee specifically handles volume, I love it. Basically what it does is it creates a bunch of planes in front of the camera or your viewport and then samples whatever your noise is at each plane. You up the samples, it adds more planes. I say planes because it's not actually creating geometry, but that's effectively how it's rendering it. It's actually really nice. It's pretty performant for Blender, and I really wish we had something similar in Unity. We have emission. Again, Eevee is a much closer representation to what Unity's render pipeline is, and Cycles is more to what you'd get if you were baking lights. So if you want emission to actually emit light, you would need to be in Cycles in order to actually have it affect things around it. Otherwise, there's bloom in Eevee, and it'll kind of have bloom, you know. Transparent, this is what you would use to mix with the back-facing in order to make something one-sided, or you could potentially mix it with other things to make it slightly transparent. Diffuse, before we had principled Bsdf, we had to use diffuse, glossy, and glass in order to make up our materials, and then we'd use various mix shaders in order to control how much of each we were getting. Glossy is basically diffuse, but it's shinier. And then glass, which has index of refraction and roughness. And then we have the big boy, principled Bsdf. This is the one that does it all. But we only primarily use 4 of the inputs. We use base color, metallic, roughness, and normal. Occasionally I use emission, but if I need emission, honestly, I'll use emission. Even more nodes. There's a lot of them. This one is a mapping node. Usually, if you have Node Wrangler installed and you use the shortcut to add mapping, it will just pop one of these in along with your texture coordinates, and this allows you to just do some basic vector math and move things around, or scale things, or rotate things. I use that all the time. Color ramp. This is another one that's really important because it allows you to take your black and white values and clamp them down, or even remap them entirely, and you can move them around however you want, or you can add color. You can take a black and white value and then take each grayscale point and turn it into a color, which I do later on, and I'll show you how that works. I have layer weight again. I really like this one. Mix shader. I was talking about this one earlier. This is where you put in a black or white value, and it acts as a mask to lerp, basically lerp between each one. That's the one thing. It amplify, it's lerp. In Blender, it's mix shader or mix RGB. It's really annoying. That's how I learned lerp. And then we have mix RGB. This one I use a lot more because it works with color rather than shaders. Something else to note about Blender is the way it handles data is it doesn't have to be the exact data it wants. It's going to try to interpret the data however you plug it in. It's going to try to interpret it as best as it can. It's kind of data ambiguous. And if you plug in color to something that's expecting a vector or normal data, it will try to do its best, but sometimes certain things don't work. But overall, I really like how it handles data. The mix RGB, we have all these different sort of operations. These are like your different Photoshop layer filters. A bunch of them are useful. I have a couple that I use all the time. And we have, all these are like different color filters that you can do independently as well. Hue, saturation, value, gamma, brightness, and then you can invert. I use this one a lot because occasionally I have a black and white value and I need a white and black value, so I just have to flip the entire thing. Okay, so let's actually get to some examples. So here we have, this looks all cool, but it's actually a single triangle. Here's the video. And so what I have here is I have the noise origin actually parented to an empty. That way when I rotate the triangle, it looks like it's panning through static fog. So let's break it down. So of course I have my texture coordinates and my mapping node, and then I just have a noise generator. You notice it is set to 4-dimensional, and I have the W value animated. That's what that yellow means. It means it has a keyframe and it animates over time. And then I just change the parameters a bit till I get it where I like, and then I use a color ramp to clamp down on a specific spot. Next up, I generate a gradient texture, and I take 2 different clamps on it using the color ramp, and then I use the wireframe data, and I invert that and use that to mix the two. Actually, you know what? Yeah, that's not right. Anyway, I use that to influence the two, so we get a brighter line on the outside and a dimmer line on the other part. Then I take that noise data that we had before and use that to mix with the transparent, and then I just mix a whole bunch more with some emission. You can see I have the strength cranked up to 250. That way we get that really nice bloom on the edges. And so that's the entire shader all in one. So this is a really simple one, but I like using it as an example because it's very pretty. Next example. This is Slaughterhouse 2, and I did a texturing pass for Panda a couple months ago. And I'm going to go into how I did the brick wall textures. So, get a good look at it, because that's all you're going to see. Nope, that's all right. We're going to actually dissect it. So, what I was talking about before is I took the normal data, and basically I was able to isolate the north-south and east-west facing parts of the walls, and then I have 2 different brick textures that I am then using that to mix between, and the only difference is that one of them is rotated 90 degrees so that it goes this way and the other way. That's the only real thing I did there. Then I use I use a color ramp to basically sort of randomize the grayscale, and then I use this is actually a mix RGB set to color, and then I just have that plugged in, and then I just put another color there and just kind of gave it all a tan color. Let's see what I do then. Right, so that's the other thing. You have access to Vertex data. So Vertex Colors, the nice thing was the entire map already had color data with it in the Vertex colors. So I was able to take that and make slightly different hue and saturation values and then mix that together based on, a Musgrave texture. So I generated more noise and then used that to have slightly different shaded areas. So you can see it's like slightly darker in certain spots. I then take that same noise texture and I clamp down a little bit further, and I use this for the roughness so that we get slightly glossier, slightly rougher areas, make it look like there's wetness or water damage. Now I broke this one down into 3 different steps. So we take the texture, the original noise, we clamp down on it, and that we use for a bump map, and you see we go sort of a dull gray, and then a white, and then straight to black. And what that gives us is a slight ramp up. So when we put that into our bump map, it's going to make it appear to be higher on the surface, and then it goes down. So it looks kind of like it's chipped plaster with brick underneath. And then I clamp down that even further to get a mask that we're then going to use to mix between the two textures. So now here, I'm mixing the two textures. I take that brick texture that we generated along with the vertex color with slight amounts of variation thanks to the noise. Mix all that together. There's a lot going on here, but you get the idea. When I first made this, I had no intention of showing it off, so I had to move a bunch of stuff around. And then the other thing about bump maps is nice is you can chain them together because each one outputs normal data. So you'd be able to plug one into the next and into the next and into the next and basically go indefinitely. It's really useful. So basically I have different black and white values coming in and we get our normal data. So you can see it kind of ramps up and then we got bricks underneath. Okay, and then everything plugs into the big chungus of principled Bsdf. So we have base color, roughness, and normal. I don't have metallic because it's a brick wall, there's no metal. So there's that again. And now let's get on to the baking textures part. So once again, I have the tutorial. I think I cover it a lot better here. So if you're interested, check that out. Also, the shader is for sale. So if you want to buy that and reverse engineer it, go ahead. I actually sold my first copy of that just the other day. I'm super happy. So firstly, if you want to bake textures, I highly recommend installing Node Wrangler. If you want to do anything with nodes in Blender, get Node Wrangler. Step 1. You go to your add-ons. Step 2, you search Node Wrangler, you check that, and you save your settings. So one other note is texture maps in Blender. Blender has 4 primary maps that it uses. We have our color albedo, our metalness, our roughness, and our normal. What most of you might realize is that Unity is a little bit different. Unity wants 3 maps. They have our color albedo, our metalness with roughness alpha, and then our normal. So just keep that in mind. So to actually bake your textures, these are the kind of things you want to set up. Firstly, you want to have a texture node in your scene with a texture created. You just click new, you choose your resolution, bada bing, bada boom, give it a name. Next, the only way to bake textures in Blender is to be in cycles. And if you are playing VRChat, I hope you have a good graphics card, so switch to graphics card, GPU compute. The other thing is there's a long-standing bug in Blender that if you do not set your samples higher than the default 64, that's the 64 is optimized for CPU rendering, switch it to 1024 or higher if you want, but your texture bakes will come out a lot faster. And then lastly, there's 2 different bake types that we're going to be using. The primary one is emission, and we're just going to use Node Wrangler to preview each of the maps and then bake those. And then the other one is normal. So firstly, we're going to preview. The shortcut in Node Wrangler for that is Control, Shift, and left mouse button, and that will preview the node that you have clicked on. Then you want to select the actual texture node and it will be highlighted in white. I actually didn't do that for this screenshot. You can see that this one's highlighted in white, but you actually want to select that one. And then once you're ready, you hit bake and it will do a bunch of processing. There'll be a little blue bar down at the bottom. Once it's done, you can save the texture and you can move on to the next one. Rinse and repeat. We're going to do rough or metalness and make sure it's the active node. Click bake. Once again for roughness. Preview, select the node, bake. Oh, of course, save the texture each time. So, normal maps are the odd one out. Normal maps are the one where you actually need to have the full shader connected to the output in order to bake them properly. So, just reconnect that back to the main output. You're going to switch from emission back to normal, and then you select the node again and hit bake. Normals usually take quite a bit, but once they're done, you can actually preview the texture just by doing the same Control-Shift-Click, and it will add a preview node. They should be this sort of weird purplish blue color. That means it's baked properly. If you see like really strong yellows or reds, something went wrong, start Googling. All right, so now we have our 4 texture maps. We have color albedo, metalness, roughness, and normal. But if you remember, Unity only wants 3 texture maps. So what do? Well, firstly, we have a roughness map, but we need a smoothness map. So how do we do that? Well, the nice thing is, roughness and smoothness, they're literal opposites, so all you got to do is flip the entire texture. What I mean by flip it is invert the values. Take all the white values, make them black, make all the black values white. There's a bunch of functions to do that in Photoshop, Blender, GIMP. The tutorial I have shows how to do it in GIMP. So first you invert it, and then you combine it with the metalness map. This is an oversimplification. If you really want to know, go follow the tutorial. You don't even have to buy the shader, just go follow the tutorial. And actually, that is the entirety of my talk. So if you're really interested in learning more about Blender and procedural shaders, these are a bunch of channels that I follow. They all have really good tutorials. Ducky3D does a lot of cool stuff with motion graphics. CG Matter is a pretty funny guy. Ian Huber, I'm sure all of you have seen his stuff on Twitter. He's a madman. Polyford is a really good one, CG Cookie. And of course, the OG Andrew Price, Blender Guru. So, thank you, TLX. That is my time. And now we can open it up for questions.
Yeah, we have a couple minutes for questions, so if anybody has any questions, please.
Hey, Shaggy.
Hello.
Do you have any suggestions for baking emission maps? Because I've had to do it before, and it's a painstaking process. And
Yes. So, in some of the other baking options, there are combination sorts of.
Yeah.
There's other baking passes that you can do. I don't have much experience with doing them, but I think for Infinite Highway, it was before I learned how to bake lights in Unity, so I actually did it.
Oh.
Whoop.
Unity bake. So it is.
No. You're back. He's back.
Did I cut at any other point in this talk? Nope.
No.
Cool. Yeah. Anyway, yes, it is possible. If you're really interested, I can probably make a little video, or I can hop into voice chat and help you work that out.
I've done it. It's just I was wondering if there was a better way, because I feel like I've got it.
Gotcha.
By
It's one of those things that's really funky. It's definitely possible. I can probably work out a pretty simple way of doing it with like 2 clicks. But without having Blender in front of me, I don't know. It's definitely possible. I've done it in the past though.
Okay. Second point, not a question, more of a suggestion for anyone watching. ZZ, as part of his shaders, has a texture packer or merger tool. And that is extremely useful because it does what you suggested at the end of getting the roughness, smoothness, and metalness mask into alpha channel. And so with the tool, you can do that within Unity, and that saves so much time. So highly recommend.
I didn't know about that. I'm gonna start using that myself.
Great talk.
Awesome. Anybody else? Awesome.
Well, there is a question in YouTube chat.
Oh, sure.
Like, I don't know. I'm not sure about the answer, but if you know, like, is there a way to, like, automatically bake, like, a GIF? Like, you would render a sequence? Like, could you render...
Yes, you can do image sequences. You can... Probably the best way to do that, I'm assuming they want an entire... Actually, you know what? Thinking about it, yes, it is possible. You would have to create the shader and then apply that same shader to just a square plane, and then you'd have to do an orthographic camera from the top and then render that as an image sequence, and then you'd probably combine that as a GIF. It's a little bit of a jank workaround, but it is doable, because you'd basically have your UV unwrap of the model, and then you'd apply that from the UV coordinates within the node editor to the plane, and that would...
Oh yeah, so you would use just UVs of a different object, but you will strap it on the actual plane.
And you just render the entire plane. Yeah. That would probably be the best way to do it.
Okay, thanks.
Cool. Alrighty.
Okay. One more question.
I've got 16 minutes left. My God. I told you I could do it in a half hour. Yeah, what's up?
There's a circle
Join on the circle.
Come sit in the circle, please.
Please come sit in the circle to ask a question. Over here.
Nope, right over there.
Come to me.
Your voice comes through the stream that way.
Thank you. I'm sorry, I joined a little late because of instance issues, but I'm just curious what you think the best shader is for exporting kind of like bakes from Blender to Unity, because I do a lot of baking in Blender. It's what I do for my job. I'm a 3D modeler by trade, like outside of VRChat. And every time that I just try to import things into standard or even into Poyomi sometimes, like I just find that there's like some discrepancies between how they show up in Cycles and Eevee and how they show up in Unity.
So unfortunately, that's just the kind of issue you're going to run into between different rendering engines. Not all of them are going to do the exact same. Ideally, they should, but unfortunately, there's just slight differences between each one and how even shaders themselves and how each one handles it. The best thing I can do is if you're baking, try to get as much data in that bake, like for instance, normals. Those are one of the trickiest things to bake. You want to make sure that when you're actually saving the image, you have as much data there as possible. But then, of course, you're going to crunch that down in Unity and do whatever else. Discrepancies between shaders and render engines, that's just how it goes. Sorry. I don't know much,
it's cool.
much about Unity shading system.
That's the answer I expected, which is fine. Thanks for your time.
Yeah. Thank you for the question.